Today we start the first lesson of angles. And we want to talk a little bit about angles, and we're going to start right from the beginning, as if you've never seen this stuff before. And if that bores you at the start, I just want to warn you that what I'm going to try to do is there is one tough question coming up in today's lesson, and I'm going to try right from the beginning and all the way through this lesson to try and aim everything I'm saying towards that tough question. And so if you've seen all this stuff before, just be patient, walk through this video with me and all the little things about angles, and then if you stick with me right step per step, that one tough example won't seem too tough at all. Okay, so I'm going to call this awesome angle lesson number 1. Now, what I first want to talk about is what an angle is. And when we're talking about angles, what we're talking about is, say you've got some direction going straight that way, and you turn and you decide, well, instead of going straight east, I'm going to start going in a new direction that way. So how much you change direction, how much you change which way you're going, that's called an angle. Now, the question is, how do we measure angles? And there's a lot of debate about that, about the history of why we measure angles the way we do. But most people think that the ancients, when they first came up with angles, they used the sun and the earth as their bases for how to measure angles. And they said, okay, the earth goes around like this, and it takes 360 days to do that, so we're going to call an angle that goes all the way around like that, we're going to call that 360 degrees. Well, it takes actually 365 days, but they thought it was 360 days, so why not use 360 as the base angle? What we get out of that is halfway around then would be 180 degrees, and a quarter of the way around, this right angle, we call that 90 degrees. We call that a right angle. And we're already ready to do a question. We already have enough information to do some angles questions. Say I've got an example like this, and I tell you that I've got a right angle, and one of the angles inside that right angle is 22 degrees. And I tell you, I want to know what this other angle is. Well, what I can do is go, okay, I know that those two angles have to add up to 90 degrees, so I can make an equation. X plus 22 degrees has to come out to 90 degrees. And I can solve that equation for the x and find out that other angle is 68 degrees. Now, you may have looked at that and said I made it too complicated by making an equation out of it, that you can just look at this question and go, well, I know to get x, I just go 90 minus 22. You may want to jump right to that step there. And when you're doing these questions, I encourage you to, jump right to that step there if you know exactly what's going on. The reason I bring up equations is because of that tough question that's coming today. And if we use equations every time, we'll find that tough question pretty straightforward. So just bear with me as I build equations every time for easy ones, so that you'll be ready for when we get to a tough one. But again, if you want to do these easy questions without an equation, that's totally fine. All right. Example 2. Oh, I want to just mention that these angles here, which were both less than 90 degrees, angles that are less than 90 degrees are called acute angles. Maybe you've seen that word before. Okay. All right, so my second example. Say I've got this situation here. Instead, I've got a straight angle like that. And I tell you, this angle here is 55 degrees. Could you come up with the value of x? And I encourage you to think in equations because it's going to get you ready for tougher questions. So with an equation, we see these two angles here add to 180. So x plus the 55 has to come out to 180 degrees. And again, you might have, in your minds, jumped to this step here, which I'm okay with, and not gone through using an equation like that. But I'm telling you, stick with me with the equations because it's going to make that tough question coming up a little bit easier. So that's 125 degrees. And I want to mention about this one here. Angles between 90 and 180 are called obtuse angles, right? And two other words I want to mention here is right here, and I'm going to put this one in red just to show that I did it later. Angles that add up to 90 degrees are called complementary angles. And these ones here, angles that add to 180 degrees are called supplementary angles. So another couple of words there. Let me highlight all the words that you need to know from here. You need to know acute, complementary, obtuse, and supplementary. Those are the big words of the day. Okay, now, I just want to talk about triangles for a bit. And with a video like this, it's not quite so easy to do, but I encourage you, if you've got a protractor around, or if you can print a protractor out and use it to measure some angles, you'll see this a little more clearly. But what I want to tell you is that if you draw any triangle you want, and you measure the three angles in the triangle, and it doesn't matter what triangle you do this with, what you'll find is when you add up those angles, it comes out to 180 degrees. And if you do this yourself, it might come out to 181 or 179 because protractors aren't the most accurate thing in the world. They get it within a degree or so, but they don't get maybe the angles perfectly. So it's easy to be off by 1 degree. But if you measured them perfectly, if you had a perfect protractor, what you'll find is that angles in a triangle, and I'll write that in a sentence, angles in a triangle always add to 180 degrees. That's very, very convenient for us that always happens with triangles. And we're going to use that a lot over the next few days. And we're already ready for example 3. That's enough to be able to do example 3. Oops. So they say solve for x here, and I've got an 85 and a 55 and an x. And so here's where that equation, and this isn't the tough question, all right? So if you're already looking at this going, I don't need an equation for this, I totally get it. I got a tough one coming, okay? So to make an equation of this, we know the angles in a triangle always add up to 180 degrees. So I make this equation, x plus 55 degrees plus 85 degrees equals 180 degrees. And you've got lots of options of how to solve this out. In fact, I'll write the line that maybe some people would have started with is they would have gone, oh, take 180, subtract the 85, subtract the 55. Maybe you just start at that step right there. And when you subtract those, I think you get 40 degrees. Okay, so we can also do this solving in triangles now. We can do angles that are complementary, we can do supplementary, we can do angles in a triangle. And just to take things up a notch, I'm going to go on this one, I'm going to go solve for, and just to prove we don't have to use x all the time, I'm going to say solve for y. I'm going to build a very specific triangle here. .30 and these are both going to be called y. Now, this one looks very difficult because there's two different y's in there like that. And why is they're both y like that? Well, this is called an isosceles triangle. Two sides equal. And when that happens, that means that there's two angles that are equal. The angles that open up into those sides, and what I mean by open up to is this y, opens up into the same size of side that this angle does here. So both of those open up into a side that's the same length. We use these little straight lines to indicate those sides are the same length. And what that means is this angle is going to be the same. Now, as far as setting up my equation, I know then that y plus 30 has to add to 180 because all triangles add up to 180. And so a little more difficult to do this question. A little bit of equation solving here. And this isn't my big sales pitch just yet, but it's getting close. That using equations for these makes your life a little bit easier. And so I got to divide that by 2, and I get each of these y's is 75 degrees. So that's a slightly tougher question because we had to really think through the isosceles thing as well. Now, side note, that was isosceles. There are two other kinds of triangles out there. There is one with all the sides the same. That's called equilateral. Equilateral. And then you can all sides and all angles equal. And then the final type of triangle is when none are the same, and we call that scalene. No sides, no angles, equal. So those are the other two types of triangles that you can run into out there. Okay, I think we're ready for the big question. The big question of the day. Here's a slightly tougher question. Say I've got a triangle and they tell me this is x plus 10 degrees. This is 2x minus 30 degrees. And this one is just x degrees. Now I've got a more challenging question where it's not easy just to think this through. And don't take that as a challenge. A challenge accepted. I can do it without an equation. I'm encouraging you to do them with equations because you're going to find questions that are just much easier to use with equations. So if you're really clever and you can think this through and get the answer for x, solve for x without using the equation, well, I'm proud of you, but that's not really moving us forward into more powerful mathematics. The powerful mathematics here is to make an equation that these three angles have to add to 180. So I get x plus 10 plus 2x minus 30 plus the x. That has to come out to 180 degrees. And so now this is, we've done equation solving. We're going to collect like terms. I see for x's, I see x and 2x and x. So that's a total of 4x. I see 10 minus 30 is minus 20. And I've got 180 over here. So I get 4x equals 180 plus 20. You see, sometimes I write the degrees and sometimes I don't. You really should, but we sort of let you away with it if you don't write degrees on every line. $4x equals 200 degrees, and then divide by 4, and I get the x equals 50 degrees. Okay, so that was the big tough question I was warming up for. I encourage you to use equations with them, and please don't get stubborn on that where you go, oh, I can do it without equations. Mr. Todd's crazy. I'm not crazy. Moving forward, for tougher and tougher questions, there's going to be questions that are impossible without equations. Maybe not in grade 9, but as we move along. So embrace it. Say, okay, I'm going to learn to use this weapon, this equation solving. And then one last side note, something that's interesting about triangles that you can use sometimes. Take a look at this triangle. But instead of just drawing the triangle, I'm going to extend this out and make what's called an external angle. So that's an external angle to a triangle. And my job in this question is to find out what that external, not external triangle, external, can I get it there? Yeah, external angle, okay? And so what I'm going to do is I'm going to give this angle here, I'm going to call this 60, and I'm going to call this one 40. And I'm really up to something here because I want to show something about external angles in triangles. And you could be given a question like this, and when you first see it, we can do this with the weapons we have so far. What I would do is I'd maybe label this angle, I'll call it y, and I'd first solve for y. I wouldn't go after the external angle first. So how I would do that is I'd go, okay, those are 60 and 40 and y are all inside a triangle. So that means 60 degrees plus 40 degrees plus y equals 180 degrees. And we'll call this step 1. So what I get is y has to be 180, subtract the 60, subtract the 40. And so y is 80 degrees. And when you've got multiple angles in a picture like this and things get a little complicated, I encourage you to write the angles you figure out onto your picture because that's going to make your life a little bit easier. Step 2 is then to say, okay, well, I've got the 80 and the x, and those have to add to 180 because that's a straight angle. Those angles are supplementary there. So I can go x plus 80, and that has to add to 180. So I can take the 180 and subtract the 80. And I get the x is 100 degrees. No problem. You can totally do these questions this way. But you might notice in the middle of all that, what's happening here is that sorry about that. I'm just trying to get my highlighter going there. There's my highlighter. Yellow highlighter. There we go. You might notice that this 60 and this 40 add to this 100 that we've solved for, and that happens with external angles of a triangle every single time. The external angle equals the sum of the two, and I'm going to call them opposite angles because they're on the opposite side of the triangle to the triangle we're working with. So that's a property you can use sometimes. You don't have to, but it's kind of a handy little property about triangles for some questions, okay? All right, I think that covers everything for day 1. A lot of the homework I think you'll find pretty straightforward because it's all angle stuff you've seen before, but there is a little bit of this solving triangles where you have to come back to this this big question here. And so let me just highlight that in red. That's the one to come back with if you're having any trouble with those type of homework questions. Just watch the development of that one again. All right.